Hi everyone, this is Masudi.
Hi guys, welcome back to our new session.
Yes, last session we talked about the how two processes can connect to each other and can share data, can pass data, and we just had a glimpse of that. It was a lot, you know. We will break it into in the next sessions. We will use them a lot, and here just we don't want to get back to the Android application. We want to write a console application. We want to do the same that we did in the Android application before, write the client application here as well. So we have this socket test. Let me rename it to server socket test. And let me copy and paste this file as client socket test. And here I just want to create the bidirectional connection just for you know the same that we did in the last session. So in the server socket, nothing is changed. It is the same code. We are creating a server socket listening on this port, and this will try to grab the socket. And just let me show you server 1 and server 2. Both of them, let's say, that are trying to let me comment these lines. I just want to show you guys that only a single process can take the port. It can be dedicated to a single process at the same time. And if I run this, it will give me an exception. I don't want to do that. Just you kind of get the idea. We are asking for the port, and then we are listening here, blocking until someone connects. After that, we are getting the input stream and we are reading all the bytes off of it, and then we print it and then close. In the client side, we want to write the code that we had on the Android. So we write a socket. After we write a socket, you know, along this port, we should also specify the host, the address of the machine sitting there waiting for us, listening. So now we are actually going to, for this example test, we are going to run them on the same machine. These two will be the processes on the same machine. So what is the address of this machine? What should the address should be here? Because last time it was a separate machine. This Android application was a separate machine, you know, actually. And we were addressing this with the IP address of the router that we have here. But this time, because we can address the same machine with two specific strings. One of them is localhost, which is also known as 127.00.1. These two addresses are the loopback address. When you address something with this localhost, it will get out of the operating system and it will again enter the operating system. It is like a feedback, a loop, you know, to the same machine. So because I know here that my server is running in this machine, I want to say 127.0.0.1. So an IP is IPv4 is specified with 4 numbers from 0 to 255. And so I'm addressing a process listening on this port on the same machine that I'm going to run. Then there is no need for this while loop. This is not a server anymore. This is the client. Then I get the output stream, for writing to the other side. And then I try to write a byte array. So this time I want to show you guys a byte array. Let me see if, yes, byte array of. So I want you guys to see that we are actually passing bytes to the other side. We cannot pass, there is no such thing as a string or integer or number. They are, of course, themselves a sequence of bytes, actually. And before sending them to the other side, we have to serialize them to bytes. And then on the other side, we have to deserialize them to the shape that they were on before. So because I know that, let me see, for example, byte 96, I think is lowercase a, I think. I've forgotten, or 65 is the uppercase A maybe, or 20, I think is the space character, or let's write them, for example, 100. So I'm trying to send these 4 bytes to the other side, and this will be the other side here. This will be the server waiting for them. It will read all the bytes, and then let's just first print them as a string. I'm running the server. Let me run it. Okay, it is actually saying that address already in use.
1, 2, 3, 4.
Yes, it is complaining because we have an address, because this application is running. Let me close it. Run it again. So it proves that just only a single process can take the one specific port at a time. So this is running now. This is waiting here. If I run this,
it will face an error.
Nope. Let's see what happens. It finished, but the server side received this. This shape here, it must be 20 maybe. 96 is, let me just, in the server side, just print the bytes array, just sequence of the byte array. I don't know if I do this, will it print the content of the array or the array itself? So let me stop it, run the server again. Okay, it's listening. Let me run the client again. It finished. In the server side, oh no, it is just printing the address of the byte array.
The previous one was better.
Yes, maybe we could do this. We could put it into a for loop dot iterator, or let's see if we can put it into some for loop here. Be inside. Yes, it's possible. Now I can print ln, print the b, and after that I'm going to have a print ln, because print will print in the same line. I want to print them in the same line, and after that let's concatenate it with a space to make it visible here. I run the server again. It is waiting for us. I run the client, and the server receives the numbers 96, 65, 20, and 100. All the numbers that we send it from this side. So we are actually sending a sequence of bytes, and the other side is receiving them. So these two parties, the client and the server, should have a common understanding on what this data means, what is the meaning, and they should interpret that data. For example, if it's in string, they should interpret it as a string. They should convert it to some kind of a string. If they know it is an integer, they should convert it to the integer, and they then use it. So if I want to spice it up, a bit, maybe we can write the chat application here in the console, maybe. So again, I'm just going to throw a lot of stuff here, just to show you guys that how these things are possible. But we will talk in depth, in the upcoming sessions about all of these. So when we have the server socket, when it accepts an incoming connection, after that, we have this socket is the client. We can name this socket as the client. This is actually the client that is coming from the other side. Then we have access to a bunch of stuff, for example, we can ask for the address of the client, or the port that the client is listening on, or a lot of things, but we are interested in these two things, input stream and output stream. So if we want to send something to the other side, because socket connections are bidirectional, they are not unidirectional. They both, at the same time, they can send and receive data, but so far we have just used the client side as sending and the server side as the receiving side. but both of them simultaneously can send and receive data. So if they want to send data, they should use this output stream. If they want to receive, they should listen to this input stream. So first, I get this output stream. I val client out stream. And then I create another one, client in string, yes. And I just try to store them here. And there is no need for this while loop anymore because we want to have just a single connection here. After actually receiving the connection and after grabbing these two just input stream and output stream, then we want to listen on the input stream and write everything that is coming, and then listen here to this console and have a read line here as we had before, and everything that we write here, we want to send it
and the other side
from the output stream. Yes, and the same for the other side. It is just the same code for the other side. So if you want to do that here, we should actually do this with the aid of the threads. And I know that we have not talked about the threads in last session. Let me show you. I just used it here without just explaining it. And I want to use it again because, you know, if we want to wait somewhere for something, and as you can see here, let me run the server. This is the server. Let me run it again. So we call each application single threaded. They are single threaded. All the applications, no matter the language, all the applications that you see here, all the processes here that are running. Of course, you can see the threads that I don't have them here. I can show you later. All of them load the compiled code to the memory and they try to run the instructions of the compiled code one by one. And then, for example, they wait for something. For example, they connect to somewhere, they are downloading something. They stop there because they have a single thread. It is like a thread that you are pulling and you are, okay, grabbing one instruction at a time. We are running this. Okay, we call this function, we wait here, then that function returns, then we continue, we call the other function, we wait here. And that is pretty much all the programs, how they work. But if they want to do multiple things simultaneously on the same process, of course, because the processes are running, simultaneously. All of them are running simultaneously. If we want to do things simultaneously, we have two options. One of them is to run another process and, for example, give some tasks to the other process and tell it to do, and then connect it through the socket and wait for example, the result. This is how we distribute the tasks. The other option here is have simultaneous threads inside the same process. So when this process runs, we can create multiple threads. And we can, for example, say that, okay, this thread will run these, will start from this function, and then it will continue from that, calling that functions, and it will stop at the end. So because this socket is waiting here, and if we want to wait for after connecting, we want to wait for the input stream, all the incoming data, we should have a thread dedicated for incoming data. Also, we should have a thread dedicated for sending data. So after accepting, I create a thread here. So with Kotlin, just writing this thread, and we have this braces. I don't want to explain how it is working, what classes it is calling on the JDK. Just consider it as, okay, when we tell the Kotlin to thread this, it will make us a thread. Let me just prove that here. Let me just have if true. Let me just comment all these lines. I just want to give a feeling about threads. For example, we have 1, 2, 3, 4, 5 threads. Okay. And then inside each of them, I want to have a while true loop. And I want to print ln And also I want to have a var counter inside each of them, starting from 0. Then I want to increment the counter and print. Then I copy and paste. Let me just copy and paste the thread itself with its content. I want to create multiple threads just to show you, just to prove that inside the same process, they are running independent of each other simultaneously. So if I run this, because one while true loop will just block there, if you put a while, you can see that. Let's see how we can prove that. Let me just do it like this. Let me just stop it. For example, one of them starts from 0. One of them starts from this. Other one starts from, for example, this number. And then, because while true, let's have slip here. I know this is a lot. I know, but just I want to, because they are fast, and you weren't able to see the result here. I want at each iteration of the while, I want to slip for 100 milliseconds and then print the number. Just I want to slow things here a bit and to show you guys that they are separate. They are independent of each other. If I run it, let's see what happens. Okay, let me just. Okay, now you can see multiple numbers here: 1, 9, 2, 5, 2, 7, 3. I just waiting. Maybe I should make the slips 1 second. Let me stop it. Just stop 1 second. We have other one here. Don't get rid of that. Also the slip 1 second and 1 second. Sorry. Let me run it again. Okay, just look at here. You can see that it is like all of them are running simultaneously. One counter is 8, 9, 10, 11, 12, 13. Another counter is 10,000, 16, 10,000, 17. Other counters, now you can see that all of them are running simultaneously. But if I let me close this. If I bring it out of a thread and run it now, because this time, this while loop here, this time we have only a single counter, you can see. You know why? Because the application will stop here until this while loop finishes. And it won't finish
because it's true for them.
So it will block here. So I just wanted to show you that the threads will help to open some kind of a thread. The name actually speaks for itself, the thread. We are creating another thread that will start from somewhere else inside the same process. It will, code. Yes, it will for example, start from calling other function, and it will continue from there on. That function will call other function, that function will call other functions. It will go on until it finishes. And at the same time, this main thread will continue for itself. So let's get rid of all this. Yes. So after getting a client here, and after getting the input stream and output stream of the client, I create a thread here, and I wait for incoming data from the input stream, and then I try to print it to the user. For example, I say client in stream dot, and we should put it into a while loop, while true, because it should not stop. While true, client in stream dot read. We have a lot of read functions here that we can use. I don't want to read all bytes because it will again block. We want to read bytes by byte, single byte at a time. So we should have again a while loop. So this read function that receives nothing will return an integer. You can see that. And it will return -1 if the end of the stream reaches. But because the end of the stream won't reach, because the other side won't close, then this loop will continue forever. So let's say that while true, read, let's have this next byte, and then we can actually print this, print the next byte. But before that, I want to convert it to a character. So let's see how we can do that. To character. Yes, we can do that. So I receive a byte from on the other side. I wait for it, and I
read it and
convert it to character, and they print it. So this loop will continue forever. Then at the same time, we have other thread here, which it is also a while true loop as well. Then it will read from the console with the function. It was read ln. Yes, read line. The read line function will wait for us in the console here, and when we enter something, it will actually return it as a string. Then we will send it with to the client output string. We write all the bytes that we have in the input. So let me just put it this here, dot 2-byte array. We call the function 2-byte array on a string to actually get all the sequence of bytes, this string as a byte, as a sequence of byte. And then we write it to the other side. So the code here is done. This is actually one side of the chat application. The other side is actually the same. I can copy and paste it from here after the server socket. Everything is the same. If I copy and paste it to this side, the client, of course, is the socket that we are. Everything is the same. You can see that I didn't touch anything. Now if I run this server socket, hopefully it will run. Let me run this. So this server is running here. Let me run the client again on the other side, for example. Okay, client is running, server is running down here. You can see. Let me send something from client to the server. So it is waiting here for us. For example, I write hello from client. I enter. Let's go to the server side. We have hello from client. Let's send something from the server side to the client side. For example, hello from server. Press enter. We have it here. For example, let's say, how are you, Mr. Server? You receive it here. Thanks. Okay, you kind of get the idea here. With just maybe 10 lines of code, and I just copied and pasted to the other side. We have a chat application, a console chat application, and I can prove to you that these are two separate, the code here is the same. You can complain that the code, they are running from the same code, but we are actually running it twice as separate processes, and I can prove it to you. Here, let me just, okay. This one is the one that is running the client socket test. This one is the one that is running the server socket test. So if I kill any of them, then the specified process will be dead. So if I run it here, 1, 2, 3, 4, 1, 2, 3, 4, you can see that this process is listening, and we have two established connections. We have two established connections. One of them is listening, and the other has been connected to the other one. And they are different processes. One of them is 16551, other one is 16607. So these two processes, they are two separate processes connecting to each other, sending data.
Nice.
So this session is done here, and I know again that this was a lot,
but it was interesting. One session we can make you with UI, and then
yes. It was interesting, I
They
know.
will enjoy when it has UI and
I know that it was interesting. It was a lot, all the thread and the sleep and the socket, the input stream, output stream, serializing, sending bytes of array. You know, this is the first time maybe for those of you that don't have any experience with the programming. But this is the only way. If just look at this way, this is the only way. No matter the operating system, no matter the programming language that you are using, this is the only way of connecting two processes and sending data. This is the only way.
in two different machines.
In all of them, you send bytes arrays of no. For example, you can connect this Java application to Python application. A Python application can ask the operating system for a server socket, and then you can issue the client from here. They will connect to each other. We can actually show that to you to prove that they can be from multiple languages, the server and the client, and it will be fine, I believe. We will talk a lot about, we will explain a lot, and it will make sense the more we advance. And we will, from the next session, we will use this mechanism to actually develop some kind of a language between the client, between the customer of the shop. So the shop will be the server waiting for incoming orders, and the customer will send the orders. So it will be a socket waiting for orders, and the customers will connect to the shop manager sending orders. And then the shop manager will somehow see, okay, we have 2, 3, 4, 10 orders waiting for us to be fulfilled. And then it will try to fulfill the orders, and then it will send, for example, a message to the client that your order is ready, for example, is coming, is on the way. And it's a long journey, and just
Let's go.
Yeah, just be with us. Just be with us. Just come. Just don't lose hope. I know this is a lot, but it will make sense.
Nothing. Don't forget to subscribe.
Yes, don't forget to subscribe.
It is interesting. Goodbye. Take care.
Bye.
Bye bye.
Take care.